Hello, my name is Aaron Williams. See, I'm gonna have to flip between my face and the computer screen because I can't get a good angle over there to videotape me and the screen. But today I'll be talking about the HVAC systems on the UWF campus that we saw in buildings 4 and 40 on our April 3rd visit as a class. Now, the specific systems of focus in the HVAC system that I'll talk about today is the variable volume fan wall units, which have the variable frequency drive, the variable air volume boxes with the motorized control dampers. Now, the first component of the variable volume fan wall unit in building 4, and this is a picture of what it looks like. As you can see, there's a few fans in that unit. But there are three main goals of this variable frequency drive controlling the variable volume fan wall unit. And first, you have to set the chilled water coils and heating coils to desired temperature, whether you're heating in the winter or cooling down in the summer. And second, the VFD must be set to the desired pressure control loop of the system. And third, the variable air volume box must be set for desired airflow, which is determined by the pressure control loop. Now, a few important factors about the variable volume fan wall unit is that whether you're heating or cooling the system, cooling through the system, all of the air runs through a duct system, and these ducts are extremely vital that you do not damage them in any way, because the whole system will malfunction and you'll lose a lot of money. But whether you're cooling, for instance, the VAV box will be closed by a motorized control damper to a certain flow rate so as to avoid freezing the unit. And when you're heating the building, the motorized control damper will become more open so as to avoid overheating the system. Now, the system that is used to sustain the variable volume fan wall units in Building 4 is known as the direct digital control system. Now, we saw this system when we went to our visit of Building 40, and this is just a picture of the computer and all the components that it is controlling throughout the system. Now, this DDC, this short term, is used to regulate all the components of the HVAC system, and it uses a centralized program to set a desired standard, whether it be in the summer or winter time. And the DDC is also set with alarms, timers, logs, and schedules to feed the main hub and let the people know that are controlling the DDC what is going on. And there's only one person that is required to be sitting at the DDC at all times, but that is 365 days a year. So that's a very important job. Now, the three main goals of the DDC is first to check the status of the system, whether it be taking trends of the problems, changing the settings based on these findings. And the second goal of the system is it uses this information that it takes note of to control the system as a whole. It then integrates this information gathered towards the individual components of the HVAC system as a whole so that it will work better and more efficiently as a unit. Now, the reason why we use DDCs is because it is a computer, and we are humans, and we can only do so much, but the computer itself can run complex equations to solve the various problems that the DDC may find on a day-to-day basis. And it deals with unoccupied time, such as holidays, time schedules, and the noted trends that it takes throughout the day. So like whenever the whole campus is gone for Christmas break or summertime or spring break, there's always someone at the DDC monitoring how the HVAC systems are running, even though there's no one really in the buildings to take that are getting from these air conditioning units or so forth. Now, the DDC's main goal is towards total automation of the HVAC system, so as to remove human error and be more efficient as a unit. Now, the systems that we saw in Building 40, however, when we went there as a class, those were massive systems, and we got to see the chillers, and there were 4 of them. They cost $1.2 million each. That's about $4.8 million per pop. Per chillers for the system. And the boilers, which 7 of them, about $85,000 each. So that'll be about $500,000 rounded up. And the energy consumption per month was around $300,000. It varied from $260 to $330, and the total energy consumption varied from about 3.3 million to 3.6 million. So I put 3.6 million because that's the higher number. But all in all, it's a very important aspect of HVAC system. The HVAC system is very vital to the campus as a whole, and it obviously takes a lot of money to run, and the DDC is very vital toward that. In conclusion, HVAC systems are vital to the smooth runnings of the UWF campus as a whole, and the variable volume fan wall units that we saw in Building 4 have the VFDs, the variable frequency drive, and the variable air volume boxes with the controlled dampers to control the pressure that the fans are running throughout the building. They are important components for the system to work. These VFDs and VFBs also have sensors that send information to the DDC, so the DDC can compile that information and make trends and just be more efficient in the future. It gets smarter every day with the information that it receives, whether it's in the summertime or the wintertime. And the final aspect that we saw today was the direct digital control system, which is in the main hub in Building 40. Now, this analyzes all the information gathered and decides what must be done. Now, these systems are all necessary and vital for the smooth running of the HVAC systems as a whole, but we focus mainly on Building 40 with the variable volume fan wall units. And so yeah, this is my presentation, and I hope I could inform you on some of the things that go into these certain HVAC systems. Thanks.